All right, greetings, math people. So today it's an issue of geometry. So I have this triangle here, and I want to find the area of a triangle. And everyone knows the area of a triangle is 1/2 the base times the height. But I want to figure out a way to find the area of this triangle without needing the height. If perhaps I just had all three sides, A, B, and C, I want to find a way to find the area of the triangle just knowing A, B, and C, not being able to determine the height. Because if I don't know these angles, it's going to be very difficult to determine the height. So I want a very holistic method for finding the area of a triangle. So let's see if we can construct it. So you see here on my triangle, I have angles A, B, and C, and the corresponding sides opposite those angles, A, B, and C. So I'm gonna try to base my method of finding the area without the height on the standard formula where we find the area with the height. So I'm gonna construct the height. So I'm gonna say my base is A. So I'm gonna construct a height perpendicular to the base, and I'm gonna call that H. Now, there's a right triangle here. This is perpendicular to the base. So I can use some right triangle trig here. And in fact, I can say that the sine of C, sine is opposite over hypotenuse. I can say that the sine of C is H over B, which in turn means H is B times the sine of C. So this is H, my base is A. So therefore, based off the normal formula for the area of a triangle, 1/2 base times height, the area here is going to be 1/2 the base, which is A, times the height, which is B sine C. All right, so there's a formula I can use to find the area of this triangle. But again, this formula is based on the fact that I know angle C, and I'm trying to develop a formula where I don't need to know angle C. So let's play around with this a little bit and have a little fun. All right, so let me rewrite that formula. So the formula was A equals 1/2 AB sine C. I would like to multiply both sides by 4. So 4A would be 2AB sine C. All right, cool. We're just doing a little algebra here. Next, I would like to square both sides, please. So 16A squared would be 4A squared B squared sine squared C. Now, why did I want to multiply by 4, and why did I want to square? Well, what squaring did is it gave me sine squared, what I can manipulate some trigonometric identities, Pythagorean identities in particular, and multiplying by 4, which made this a 2, made it, when I squared it, made this number a good perfect square. So now I'm gonna utilize the Pythagorean identity where sine squared C is 1 minus cosine squared C. Now I know what you're saying, you still haven't got rid of angle C, but I'm working to it. What I'm doing by bringing cosine C into the play is I'm bringing in the law of cosines. And when I bring in the law of cosines, it's going to allow me to correlate angle C, the cosine of angle C, with just some sides. So it's going to make me do it. It's going to allow me to do a nice little substitution there. So let's do it. So 16A squared then will be 4A squared B squared times 1 minus cosine squared c. Cool. Let's distribute. So if I distribute 4a squared b squared times 1 is of course 4a squared b squared. And 4a squared b squared times cosine squared c is of course 4a squared b squared times cosine squared c. All right, so now what can I do? Well, now this looks like everything here is like a perfect square. Of course it is because I squared. So let me write it in that manner. So this 4a squared b squared is 2ab squared. 4a squared b squared cosine squared c is 2ab cosine c squared. Now, if you know the law of cosines, this should look like a part of the law of cosines. And again, it's what I was trying to do to get rid of the cosine c. So let me remind you of the law of cosines. So the law of cosines say to find side c is that c squared would be a squared plus b squared minus 2ab cosine c. And if you look what we have here, we have 2ab cosine c. So if I solve this for 2ab cosine c, I'll move the 2ab cosine c over here, and so I have to move the c squared over there. I'll get that 2ab cosine c is a squared plus b squared minus c squared. So I can do this substitution and I will finally get rid of the angle. And I will have a formula that's based solely on the sides, not on any angles anymore. So let me go ahead and do that substitution. So again, the 2ab cosine c is going to become a squared plus b squared minus c squared. So let's go back to this paper. And again, let's turn this 2ab cosine c into a squared plus b squared minus c squared. So this is 16a squared. So 16a squared equals 2ab squared minus a squared plus b squared minus c squared squared. All right, so now we have something pretty good. So our formula now is dependent only on sides, not on any angles. But let's clean it up a little bit. So let's make it a little more presentable. It is a usable formula now. Of course, I would have to divide by 16 and then take the square root for it to truly find a. But let's clean it up just a tad. So this is the difference of squares. So remember, a squared minus b squared is a plus b times a minus b. And so I'm going to do this. This is like my a and this is like my b. There are two squares and we're taking the difference. So I'm going to factor it in the a plus b, a minus b form. And so what I'm going to have is I'm going to have 2ab plus a squared plus b squared minus c squared. And then 2ab minus a squared plus b squared minus c squared. So let's do that. Look at this, have this paper just for reference. All right, so it's still 16a squared equals and so we'll have, I'm factoring difference of squares, so 2ab plus a squared plus b squared minus c squared times 2ab minus a squared minus b squared, and that's going to turn to a plus c squared. All right, so far so good. Now let me reorder these items, and when I reorder them, the way they look should remind you of something. So I'm gonna put the a squared and b squared in front. Well, I'm gonna put the a squared in front of this guy and the b squared after. Over here, I'm gonna put the c squared in front, and I'm gonna put the 2ab in the back. So it's gonna look something like this. So again, I'm gonna move this a squared to the front. So this a squared plus 2ab, then I'll put this b squared plus b squared minus c squared. Cool, and here I'm gonna put this c squared in the front, c squared, and then minus a squared plus 2ab minus b squared. Now, these first three guys, that's a plus b squared. Now, that's what that is. This is a plus b squared. And here, if you factor out this negative sign, in fact, let me factor out the negative sign. So c squared minus, this would be a squared minus 2ab plus b squared. And so this is a minus b squared, a plus b squared, a minus b squared. So let me write it as such. So this is a plus b squared minus c squared. And this is c squared minus a minus b squared. Do I need another parenthesis? Yes. All right, cool. I hope that looks as beautiful to you as it does to me. Now, we got difference of squares again. Let's go ahead and apply the difference of squares again, see where it leads us. When you see the difference of squares, you gotta exploit the difference of squares. Come on now. So let's see, so we'll have 16a squared. And again, difference of squares, so this will be, this will be a plus b plus c times a plus b minus c. So a plus b plus c times a plus b minus c. And this one, when we factor this one, this will be c plus a minus b, and then c minus a minus b. So first we'll do c plus a minus b, and next we'll do c minus a minus b. So when I do minus a minus b, that'll be negative a and positive b. All right, we're almost to the point where we're gonna have the formula looking the way we want it. We're almost to that magical moment. And I want to do one thing before I get to that magical moment. I want to define a term real quick that I'm going to use here. And this term I'm going to define is going to be called S. It's called the semi-perimeter, and it's simply the sum of the sides divided by 2. So I'm just defining this term. Nothing to prove. I'm saying this is what S equals. And since I'm saying S is a plus b plus c divided by 2, you could also say, if you want, that 2s is a plus b plus c. All right, cool. Now, if you look at it, if you look at these four guys here, this guy right here, that's 2s. That's what I just defined as 2s. This guy is 2s. This guy is close to 2s, but look, instead of a plus b plus c, it's a plus b minus c. So what do I have to do to 2s in order to turn this plus c to a minus c? I got to subtract 2c from it, because c minus 2c would be negative c. So again, this guy here is 2s. This guy is 2s minus 2c. Look at this guy. This is a, well, c, a, negative b. Pretty much everything here, but the b is negative. Same deal. What do I have to do to make this b negative? Subtract 2b from it. So this guy is 2s minus 2b. And if you follow what we've been doing, this is a negative a. And so this guy is 2s minus 2a. All right, now we're getting to something that's going to be very presentable. So let me write this. And, you know, I don't really want to go C to B to A. I'd rather go from A to B to C. So I'm going to reorder these, if you will. These are being multiplied, by the way, so we can put them in whatever order we want. So we'll get 16a squared equals s times, equals 2s times 2s minus a times 2s minus b times 2s minus c. Now, doesn't that look nice? Now, again, we still have this 16 here and we still have the a squared, so we have to deal with that. But if you notice, we have 4 terms here and they all have 2's. So we can factor out 4 2's, and 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So when we factor all of these 2's out, it's going to give us 16. So 16a squared equals 16s. So I'm factoring out all the 2's times s minus a times s minus b times s minus c. And we can divide by 16. And now again, this is a squared and we want a formula for a. So of course, all we have to do is take the square root. So our formula is that a is going to be the square root of s times s minus a times s minus b times s minus c. So there you have it. Here's a formula you can use to find the area of any triangle as long as you know the 3 sides. You don't have to know the height. You don't have to know any angle. We'll see you next time.